Hey everyone, and welcome back to STEMify. In today's video, we're going to be learning implicit differentiation, one of the most important topics in AP Calculus AB. Have you ever seen an equation like x squared plus y squared equals 25? And then wondered, how am I supposed to take the derivative of this? Well, then this video is for you. By the end of this lesson, you'll be able to solve implicit differentiation problems step by step and avoid some of the most common mistakes students make. On a quick note, throughout this video, I'm going to be using dy dx instead of y prime, but they both generally equal the same thing. It's just that dy dx makes it easier to see what's happening. So let's go back to this problem right here. X squared plus y squared equals 25. Up until now, we usually worked with equations where y is isolated. For example, y equals x squared. As we can see, y is isolated, and you take the derivative with respect to x, which is just dy dx equals 2x. That's it. But in this equation, as we can see, x squared plus y squared equals 25, the y is not isolated. Obviously, this is a little bit simpler equation where you could actually isolate y and make y alone, but you can't do that every single time. In some spots, it's impossible to do it. So we're going to work on this simple, easier equation just to grasp the concept. So since y is not isolated, we use implicit differentiation. The key idea is simple. You take the derivative of both sides with respect to x. So let's take derivative of both sides. The derivative of x squared equals 2x. The derivative of y squared. Since this is with respect to x, right? So we have to think of y squared as a chain rule problem. So you take you do the outside function, which is 2, right? To the squared. So you do 2, and you keep the inside function just like how it is. So 2 times y, and then you multiply it by the inside function, which is just dy dx. And then remember when I said you take the derivative of both sides? So we just took the derivative of the left-hand side. We also should take the derivative of the right-hand side, which the derivative of a constant is just 0. So now this is our final problem. Here, I'll make it a little bit easier. Just 2x plus 2y dy dx equals 0. All you have to do now is literally just isolate dy dx. So in order to do that, what we're going to do is subtract the 2x here, minus 2x minus 2x. You get 2y dy dx equals negative 2x. And then you divide by 2y, cross that. So you get dy dx equals negative 2x over 2y. And we can also simplify that to negative x over y. And that's how you take the derivative. It's that easy. One of the most common mistakes that I have seen people do is, if we go back to the original problem of x squared plus y squared equals 25. The most common mistake is this. They take the derivative of 2x, which is just, of x squared, which is just 2x, and they take the derivative of y squared as 2y, and then they stop. They forget that this is a chain rule problem. It's with respect to x, right? So you have to multiply the dy dx. Many people forget the dy dx, and they continue, and they just do equals 0, and they start solving, and then they're like, ooh, where's my derivative? Where do I go? I don't know where my derivative. I'm solving for y. And then they try to take the derivative of y, and it's a whole different mess, and you're not going to get the right answer. So always try to avoid this problem. Make sure if the question's with respect to x, make sure that y's are not like a normal. You use chain rule on those if you can. Okay? And also, most common, make sure you never forget your dy dx's, because that's how you differentiate. The dy dx is how you get to your final answer. Now let's try a different example. Let's try x squared plus x cubed plus y cubed equals 6. Again, let's notice that we differentiate y cubed, which is just going to be, because we can't isolate y cubed right now, right? So you take the derivative of x cubed, which is just 3x squared, plus, and then you got to use chain rule again. So you take 3 times the inside function, which is y, and then make sure this is squared, obviously, right? So because 3 minus 1, the exponent, so 3y squared times our derivative of dy dx, which is our inside function, equals the derivative of a constant is just 0. And now you just got to isolate the dy dx. Subtract the 3x, so you get 3y squared times dy dx equals 3x squared. And then you divide by the 3y squared, so dy dx equals 3x squared over 3y squared. And then obviously you can simplify this to x squared plus, that was a little bit weird, x squared there we go, 3x squared over y. So now let's try to do a slightly harder example. Let's try x times y equals 12. This seems pretty easy, right? However, the problem is we have to use the product rule now. So if you remember the product rule, all it was is it's the function of f prime of x times g of x plus f of x times g prime of x. So that's a product rule problem, or the equation. And now we're just going to apply that here. So we're going to use the f of x, or that function is going to be our x, and the g function of g of x is going to be our y. Now, all we do is, let's go back to our equation. So f prime of x. So the derivative of x is just 1. The derivative, and then we keep y how it is, so just y, plus we keep x how it is, since f of x just stays the same, so x, and then we take the derivative of y, which is just dy dx. And then obviously, remember when I said in the beginning, in implicit differentiations, you differentiate both sides, the left hand and the right hand side. Don't forget that. So derivative of a constant is always 0. And now what you do, you just isolate the dy dx. So you subtract the y, so you get x dy dx equals negative y. Divide by x, you get dy dx equals negative y over x. And that's your final answer. And this also works for the quotient rule, and sometimes you can also use this on the chain rule. Now, let's try a little bit of a harder problem. And let's try x squared plus x times y plus y cubed equals 7. Now it's your turn. Pause the video and try it yourself. And I will go through this, and let's compare answers at the end. So now let's see how you did. We're going to first differentiate both sides of the equation. So the derivative of x squared is just 2x. And then remember here, we have to use the product rule. So it will just be y plus x times dy dx plus, and then here the y cubed would use chain rule. So when you do use chain rule, you would get 3y squared dy dx, and the derivative of a constant is just 0. And now you just gotta isolate. So we're gonna subtract the x, 2x, we're gonna subtract the y. I think I'm gonna use a different color now. So when you subtract the minus 2x and then minus y, which we do that from both sides, minus 2x minus y. So you get x times dy dx plus 3y squared dy dx equals negative 2x minus y. And now you're wondering, how do I isolate the dy dx? I don't know what to do. all you do is, remember, you can take out the dy dx from both sides. So you can keep dy dx, and it will just be, you can do x plus 3y squared. And it still equals our negative 2x minus y. And now all you do is divide this x plus 3y squared, and you get dy dx equals negative 2x minus y over x plus 3y squared. And that is our derivative. That's your final answer. If you got that, great job. Now let's try to do this like a real AP Calculus free response style problem. Suppose it also asks you for the same derivative up here of this derivative. It also says that suppose a point, I'll use a different color so we can differentiate. A point 3, 2 lies on the curve. Find dy dx or at that point. So if they give you a point and they say, what is dy dx? You pretty much would do what we just did here, differentiate, solve for dy dx, and use, I'll write the point right here as well, and just plug in those numbers for x. So when we want to say dy dx at the point 3, 2, you plug in the 3 for x and 2 for y. Negative 2 times 3 minus 2 over 3 plus. There you go. And then you would just simplify to negative 6 minus 2 over 3 times 3 plus 12. And your final answer should be negative 8/15. And then that's how you would answer the question. And sometimes what they would do is, for example, you might see in an FRQ portion as the first problem is where they would say, they'll give you the problem. So this is the equation. Find for example, the problem might be find dy dx equals the answer which we got here, which is negative 2x minus y over x plus 3y squared for this equation. And the equation would just be this first equation that we got up there, which was just x squared plus x, just erase that, plus xy plus y cubed equals 6. So they would actually sometimes in a problem, what they would do is they would actually give you the answer, because in a free response questions, you have multiple parts like A, B, C, D, and they don't want you to get the first point wrong and then you're not able to get any other point after that. So they would actually tell you what the derivative is, and then in order to earn the point on the FRQ, you have to prove your steps. So you see how all of our steps here, you have to prove that in order to earn that point. And this is where they're actually trying to test if you know the steps more than actually just memorizing it. So if I were you, I would start practicing the steps on how to do it more than memorizing, and understand why we do each step. So let's do a quick little recap on implicit differentiation. There's 3 things you do, okay? First thing is, if you can't isolate the y, then isolate the y. And then the second thing is differentiate both sides, the left-hand side and the right-hand side. And then make sure you also add dy dx to your y terms, because make sure this is respect to x, not respect to y. So you have to add that dy dx. It's like you're using the chain rule. And then the third thing is solve for dy dx, isolate dy dx, and that's your answer. So if you're ever given a point, you can literally just substitute it back at the end. Substitute the point back in your equation. So if this video helped you, make sure to subscribe to STEMify for more AP Calculus AB and AP Chemistry content. My goal is to make STEM concepts simple, clear, and easy to understand. And if there's another topic you'd like to learn more about next, leave it in the comments below. Thank